So we're given a line which goes from 0 to 1 plus I, and then we're going to integrate z squared with respect to z over this line. So first of all, let's draw the line on the graph. It starts at 0 and ends up at 1 plus I. That's 1, that's I, and it goes in this direction. So how are we going to find this integral? Well, when we're integrating lines, so this is a line integral, what we're going to do is use this formula. So let's just write it here. Integral over the line of f of gamma t times the integral of gamma t dt. Now the function here is z squared, so basically this will be squared when we come to put the gamma in there. But first of all, we need to find out what the gamma is by doing a parametrization. So what we do know is that we can let alpha equal the start point, which is 0, and beta equals the end point, which is 1 plus I. So standard parametrization for a straight line is we take the start point and multiply it by t minus 1. Sorry, 1 minus t. Let's put that the right way around. 1 minus t. And then we add beta times t. Okay, where t is 0 to 1 in this case. Okay, so plugging in 0 for this term cancels out, and beta is 1 plus I. So basically we just end up with 1 plus IT. So now we can say that our parametrization with respect to t is basically 1 plus I times t. Okay, while we're at that, we can work out the integral of this parametrization. So we can say the integral is basically just going to be 1 plus I. Just leave the equal sign there. So that's that 1 plus I. Okay, so how are we going to handle the integration parameters? So the line integral is basically what our t is here, because we're integrating with respect to t. Our t goes from 0 to 1. So let's plug that in. So it goes from 0 to 1. F of gamma t, so we've got 1 plus I t, and the function is z squared. So basically what we're going to have here now is 1 plus I times t squared, and multiply this by 1 plus I with respect to t. Okay, let's work out what we've got here. So 1 plus IT squared. So if we square that, let's just work that out. Let's just work that out here. Let's do it here. 1 plus I times t will give us t plus I t, and then square that, so then we'll have t plus I t, t plus I t. So square that out, we'll have a t squared. IT times t will give us IT squared. IT times this t will give us IT squared. And then IT times IT, well, that gives us I squared t squared, which will be minus t squared. Okay, so therefore these will cancel out, the t squares will cancel out, and then we'll be left with 2it squared. So let's write that in there now. From 0 to 1, 2it squared, 1 plus I with respect to t. Okay, how are we going to deal with this? So let's take this 1 plus I out, that's just a constant. So now we'll be left with 1 plus I. and then integral of 2i t squared with respect to t. Okay, so we can take 2i out of here as well. So this is just a constant multiple as well. So 2i, let's bring that out front. So we'll have 2i, 1 plus I, and then we're just left with the integral. Oh, I've got the parameters here, let's put them back in, so forget those. T squared dt. Okay, so this will just end up multiplying that out. 2i times 1 is 2i. So that's 2i. 2i times I is minus 2. So 2i minus 2. And then integrate t squared. That's just t cubed now. So then we've got t cubed over 3 from 0 to 1. Okay, so t cubed when it's 1 is just 1 over 3. The 0 will cancel it out. So then we'll be left with, let's bring it up here, 2i minus 2 times 1/3. So basically that will end up with, bring it into proper Cartesian form, minus 2/3 plus 2/3 I. And that will give us the answer to our original question. Okay, a lot of interesting things there to look out for. F of gamma t, integrate the gamma t after you've found your parametrization. That's obviously an important step. Without that you can't do anything. Then after that it's just all algebra. Okay, thanks for watching.